The trig functions. Before we do that, I would just like to take a moment here to review the right triangle definitions of the trig functions. So I'm going to start off with a picture. I'm labeling this angle theta, and if that is angle theta, then the side opposite theta is this side. The side adjacent is the bottom side here, and the hypotenuse is, of course, this side, the longest side, the side that's opposite the 90 degrees. So with this picture, then, I can say that the sine of theta is equal to the opposite side over the hypotenuse. The cosine of theta is equal to the adjacent side over the hypotenuse. Tangent theta is the opposite side over the adjacent side. And cosecant theta, these are the reciprocals of these three main trig functions. So the cosecant theta is the one that goes with sine theta, and it is its reciprocal hypotenuse over opposite. Secant theta is the reciprocal of cosine of theta, so it's hypotenuse over adjacent. And cotangent of theta is adjacent over opposite. So these 6 trig definitions are defining a relationship between the angle theta and a ratio of 2 sides of the triangle. So it's made up, the sine function then is made up of an input, which is the angle, and an output. And the output is the ratio of 2 sides of the triangle. Specifically for sine, it would be the ratio of the opposite side over the hypotenuse. And that's true for all of the 6 trig functions, right? An input and an output. Input is the angle, output is the ratio of the 2 sides. Okay, so what do we do though if the angle, what if theta is greater than 90 degrees? So this poses a bit of a problem because we no longer have a triangle to draw, a right triangle to draw. We have the 90-degree right triangle there, and then no more room to draw another 90-degree angle or one that's bigger than that. So the whole triangle idea then is not going to work for us. Yet we know that certainly these have values. For example, if you plug into your calculator the sine of 120 degrees, for example, you'll get an answer back out. So it appears then that these have values, but where are they coming from? How are they defined if we don't have these a nice right triangle to look at? Okay, so we're first going to start by putting our angle on a coordinate system. So I'm going to draw the XY coordinate system. And we can put our angle on this coordinate system by putting the initial side along the positive x-axis. And that always happens. The initial side on the positive x-axis. And then we're just going to spin around to get the angle in there. The side here is called the terminal side. So the initial side along the positive x-axis, the angle theta, and then that terminates on the terminal side. This is called an angle in standard position. So theta is in standard position. Okay, and that's how we're going to consider all of our angles now, are in standard position. Okay, so when we look at an angle then that is bigger than 90 degrees, we still want to think of these trig functions as the ratio of 2 values. So let's go back, let's draw again our angle. And we're going to draw an angle here in, again, standard position, and we're going to draw it in the first quadrant because we really know how to handle things in this first quadrant, if you think about it, because that's the 90-degree angle, 90-degree triangle that we have been talking about. Okay, so here's my terminal side. I'm going to look at a point on the terminal side, and I can look at any point on the terminal side. Here's my initial side on the positive x-axis. So I'm going to label this point on the terminal side x, y. Okay, so I have an x, a y. Okay, so we have this point x, y, and the angle theta. So here's this distance x, here's the distance y, and then we're going to call this distance from the origin out to the point, we'll call that r. Okay, so x, y, r, and theta. Those four pieces are the things we want to concentrate on: the x-coordinate, the y-coordinate, r, and the angle theta. Okay, we're going to make a note here that that r always has to be positive. Okay, r is positive always. It's the distance from the origin out to the point x, y. Okay, now I'm going to write down my my 6 trig functions looking at this picture here. So I'm going to say the sine of theta. Now, when I look up here, we're used to thinking of, again, this right triangle. So the sine of theta is the opposite side, which I've labeled y, and over the hypotenuse, which is r. So it's still going to be opposite over hypotenuse, but instead of calling it opposite over hypotenuse, I'm going to call it y coordinate over r. Cosine of theta. Okay, that would be the adjacent side, which in our picture is the x-coordinate over the hypotenuse, r. Tangent of theta. Well, that's the opposite side over the adjacent side, but in our picture, again, this is y-coordinate over x-coordinate. And then we have the 3 reciprocal functions. So that's cosecant of theta equals r over y-coordinate. We have secant theta equals r over x-coordinate. And cotan theta equals the x-coordinate over the y-coordinate. Now, by making these definitions instead of opposite, hypotenuse, adjacent, and we've made them now all in terms of x, y, and r, these coordinates then can take place in the first quadrant, second, third, fourth, any of the 4 quadrants. And that's what allows us now to think of theta as something bigger than 90 degrees. Okay, so now these are 6 trig definitions that we're going to use pretty much from this point on, so that it allows us to talk about trig functions of theta larger than 90 degrees. Okay, well, let's take a look now at an angle that is not bigger than 90 degrees. Let's say our angle is 233 degrees. Okay, let's say our angle is 233 degrees. And we're interested in the 6 trig functions for 230 degrees. Let's further say that we know that the coordinates on the terminal side are -3, -4, approximately. Okay? So suppose we know the coordinates of one point on the terminal side of this angle, are -3, -4. Okay, so let's see what that does for us here. We're going to draw our picture. Picture is going to look like this. Have an x, y coordinate system. Now let's think about where 230 degrees would fall then. 90 degrees would be straight up on the y-axis. 180 would be on the negative x-axis. So let's see, this is 180 degrees. If I add another 90 degrees, that would put us down here at 270. So we're looking at 233 degrees. So it would be somewhere here. Okay, so here's my initial side I've drawn. Here's the angle theta of 233 degrees. And I've been told that the approximate coordinates of a point on this side are -3 and -4. Okay, and the question I have, or let's look at some of the trig functions. I don't think I'm going to look at all 6. I'm just going to look at the main 3, sine, cosine, and tangent. Okay, so what we said before was there's always 4 things we wanted to get out of a picture. We need to know what the angle is, and I do. We need to know what the x-coordinate is, and I know what that is. The y-coordinate, we're good there, and r. And r is the thing that we're missing. Remember, r is the distance from the origin out to that coordinate. So if we need to know what that distance is, let's just draw a little picture here. We know that, let's see, x is -3, so that distance is -3. Y is -4, and so to find r, it looks like we could use Pythagorean theorem. Okay, and the Pythagorean theorem is going to go x squared plus y squared equals r squared. So in our case here, it's going to be -3 squared plus -4 squared equals r squared. That's 9 plus 16 equals r squared. 25 equals r squared. R equals plus or minus 5. But if you recall, we said that r is always going to be greater than 0, so we're going to say r is 5. Okay, so now I think we're ready. We know what x, y, r, and the angle is. So let's write down some trig functions then. The sine of 233 degrees. If you recall, we said that's the y-coordinate over r. Our y-coordinate is -4, r is 5. So I have -4/5. Let's see. The cosine of 233 degrees is the x-coordinate over r. Cosine is x over r. So in our picture here, that's -3 over 5. And the tangent of 233 degrees would be the y-coordinate over the x-coordinate. And in our picture, that means, let's see, that would be -4 over -3, or +4/3. Okay, let's observe a couple of things before we move on here. One is that now our sine, cosine, tangent values can be negative. Sine turned out to be negative, cosine turned out to be negative, tangent turned out to be positive, but only because it was the ratio of 2 negative numbers. So now we can have plus or minus trig values. They could be positive or negative, depending on which quadrant the angle is in. So that's one thing to take note of. One last thing I'd like to point out here before we move on to another example is I'd like you to pick up your calculator and type in there the sine of 233 degrees. Make sure you are in degree mode. Okay, if you do that, you come out with a number that's approximately 0.7986. Now, if you look back up to what we had for our picture, we had -4/5. So let's compare what the calculator is saying for the sine of 233 degrees for what we came up with for the sine of 233 degrees. So what we said was the sine of 233 degrees was equal to -4 divided by 5. So if you enter that into the calculator, you'll get -0.8. which is pretty close to what the calculator is saying. It's not exact. Remember we said that the coordinates that we were using up there, the -3 and the -4, were approximate coordinates, but it kind of gives us maybe a little warm fuzzy feeling that we're getting the same answers, or approximately the same answers as what the calculator is getting. And you could check that for the other trig functions. You'll find the same thing. Okay, so let's move on to an example we might see in the book. Okay, we're going to take a look at this example. Given the point 2, -4 is a point on the terminal side. Of the angle theta. Find the 6 trig functions for theta. Okay, if you notice, we never know what theta is. They're just telling us we have some angle theta, and if we look at what the terminal side is, where that terminal side is, we're given a point on the terminal side. Okay, my best advice here, and I'm going to say it in big letters here, draw a picture. Really. Okay, so here's my picture then. My XY coordinate system. I'm going to locate the angle theta by looking at where this point is on the terminal side. So let's see, we're at 2, x equals 2, and then y equals -4. So that's 1, 2, 3, -4. Okay, so there's a point on my terminal side. So I'm going to draw in the terminal side of the angle. Okay, so remember the angle that's in here. It's this one going all the way around this way. That's theta. So whatever theta is, it's bigger than 90 degrees. It's going to put us around into quadrant 4. I'm going to label the coordinates of this point on the terminal side. Coordinates are 2, -4. Okay, so once again, we have the theta, we have 2, we have -4. The thing we're missing is r again, that radius. So I'm going to say 2 squared plus -4 squared equals r squared. So that's 4 plus 16 equals r squared. That's 20 equals r squared, so r equals the square root of 20. Okay, so I think we're ready to write down the 6 trig functions. It would be the sine of theta equals the y coordinate over r. So my y coordinate is -4 over the radius, which is square root of 20. Cosine of theta is equal to the x coordinate over r, which is 2 over square root of 20. Tangent of theta equals the y coordinate over the x coordinate, which would be -4 over 2, or -1/2. And then we have the 3 reciprocal functions. This would be the cosecant of theta equals square root of 20 over -4, and secant of theta would be square root of 20 over 2. Cotangent of theta, reciprocal, would be 2 over -4, or -1/2. And I see I made an error. -4 over +2 should be -2. Again, note that we have both positive and negative values for our 6 trig functions. These are all exact values. That is, the square root of 20 is an exact value. The minute I stick this in the calculator, -4 over square root of 20, I get an approximation to this ratio. We still have ratio definitions for our 6 trig functions as we did before. It's just that these ratios are given in terms of x-coordinate, y-coordinate, and r, rather than opposite, adjacent, and hypotenuse. Okay, I'd like to look at one final example. Okay, here's my last example. It says, given that the tangent of theta equals positive 2/3 and that the cosine of theta is less than 0, find the values of the remaining 6 trig functions. Okay, so let's see what they have told us here. They've told us that the tangent of theta is equal to positive 2/3. So what they're trying to tell us there then is that the y-coordinate is 2 and the x-coordinate is 3. But let's look a little bit closer. They've also given us another clue that says that the cosine of theta is less than 0. Okay, so let's think about what that means. Well, remember that the cosine of theta is defined as the x-coordinate over r. And what they're telling us here is that that number is less than 0. Well, remember that r is always positive, always. Well, then the only way for this fraction then to be a number that is less than 0 is if the numerator was negative, because a negative divided by a positive is negative. So in telling us that the cosine of theta is negative or less than 0, what they're telling us then is that the x-coordinate must be negative. Well, does that contradict what we have over here? It says the tangent of theta is 2/3. But we just said that the x-coordinate has to be negative. Well, let's take this into account then. If we say the tangent of theta is 2 over 3, but I know that the x-coordinate has to be negative, that means that it has to be -3. Well, that forces then the top, the numerator, to be -2, because -2 divided by -3 is still positive 2/3. Okay, so they've told us then essentially that the y-coordinate is -2 while the x-coordinate is -3. Now that I know that, I can draw my picture. So that's my next step here. Draw the picture. We're drawing a picture of an angle that has x-coordinate -3, y-coordinate -2. So that puts us in the third quadrant. So let's see, I'm going to just write this down over here. X-coordinate is -3. While the y-coordinate is -2, which still gives us that ratio of positive 2/3. Okay, so here we are, drawing the angle and terminal on the terminal side here. It's my initial side. Here's theta. Okay, and here's my point on the terminal side, and the point is -3. -2. So again, we need to know what r is. So we're going to say -3 squared plus -2 squared equals r squared. It's 9 and 4. R squared is 13. R is plus or minus the square root of 13. Again, r is always positive, so I know r is positive square root of 13. Okay, and now we're ready to go again. We know what x, y, r, and theta are. Alrighty, so sine of theta. Okay, you know this now. It's y over r. So that's -2 over square root of 13. Cosine of theta is x over r. That's -3 over square root of 13. Tangent theta was given. But let's just check to make sure that it is what it is. That's y over x. That's -2 over -3, or positive 2/3. So that checks out. And then the 3 reciprocals. So that's cosecant of theta equals square root of 13 over -2. Or we can put the negative out in front of it all, like that, negative square root of 13 over positive 2. And let's see, secant of theta. Square root of 13 over -3, or negative square root of 13 over 3, putting the negative in front of everything. Cotangent of theta is the reciprocal That would be x over y. So that's -3 over -2, or +3/2. Okay. Take note again that we have both positive and negative values for all of our trig functions. I think that's it. Hope this helped.